In the previous video of unequivalent exponential form, I showed how the logarithmic form can be equivalent to the exponential form. And I used a little blue base to show that this can be done for any base. And I explained that the base cannot be negative, and it cannot be 0, and it cannot be 1. But the base does not have to be an integer, it can be a real number. For example, it could be log 2, but it also could be log 2.1. It could also be log 2.5. A very special number, 2.718 continued, which is an irrational number, is represented by the letter E. And then we can write the logarithmic form as log E to the x. And this is more accurately written as ln E to the x, which can be further abbreviated to ln x. Notice we don't bother putting the E, inserting the E anymore. It's okay just to write ln. Whenever we write ln, we know it's going to be to the base E. So this logarithmic form can be written in exponential form. So these two logarithmic forms can be now written as e to the power of y, which is x. It's probably clearer if we use some example. This can be written as e to the 7 is equal to x. And another example I might use is ln x is equal to -3. That will just become e to the -3, which is equal to x. And what about ln x, which is equal to e? That's just going to turn out to be e to the e, which is equal to x. And you probably notice that all of the bases are e in this exponential form. So the basic pattern is the same thing for each one. You're just changing, putting it into the base e, and as we did before, a is equal to x this time. So these are all examples of natural logs being changed to exponential functions. And natural logs have their own law, so I'd like to introduce you to the laws of natural logarithms in my next video.